So hopefully you did it. For quite a few of the parts, so that's why I haven't even, this answer key was already on it. Hope you looked at that. I shouldn't be showing you anything new at this point. But I want to tell you the reasoning for this pretty easy handout. So hopefully number one was pretty easy. But the biggest reason why I signed this now is if I had to pick the one word that many of you, 30% of you, are going to struggle with the entire semester is the word at least. Sounds kind of silly because right now sitting here you might actually know what that word means, but let's make sure of that first. So what does the word at least mean in your own words? I don't care about tornadoes. What does at least mean?
Like, so on the worksheet, you're not.
Oh, I don't care. Sometimes if I move it away from tornadoes, people predict.
So like at least I think of like it has to be at least that number. So it has to be 4 is like the lowest.
Good, and that's all exactly correct. Let's just say it a different way. So 4 and go bigger or smaller? Go bigger. So a lot of times, so at least does include that number and more. There's going to be certain chapters in the book we're not really going to care that it means that number. The biggest thing is that you know it means and more. Going bigger, you have to be at least 21 to drink legally in America, right? 15-year-olds cannot drink legally. When we get to shapes and areas in a month, a lot of people are going to be looking at it as less than, and that is not correct. It has to be go bigger. In this case, that number and bigger, okay? So it's just kind of start reminding you of that. So, well, hopefully you filled in the relative frequencies. I didn't even show it to you here. The frequency divided by the 60. So what proportion of time were there at least 4 tornado warnings? So what does at least 4 mean? 4 or 5 in this case. So you would add up the 4 and the 5 case. And so again, I'm just trying to give highlights, but there were 2 ways you could have done it, and either way is perfectly fine. You could have come at it from frequency, added up the 12 and the 8, they're pretty easy numbers, 20 divided by 60. Or since you already had calculated the relative frequencies, then you could have added up those 2 relative frequencies. I think it was 0.2 plus 0.1333. Yeah, okay. Now part C, it said at least 1, right? Yeah, at least 1. Also on that one, so that means 1, 2, 3, 4, 5. There's 4 ways you can do this one. You could have added up those frequencies you needed. You could have added up the relative frequencies. You'd be adding up the 1 case, the 2 case, the 3 case, the 4 case, the 5 case. Adding up 5 numbers is not that hard, right? But I want you to learn to be lazy. I don't feel like adding up 5 numbers. Again, I don't have mine filled in, but on at least 1, you would have added up all of those, right? Whatever numbers were there. Now, I don't want to have to add up those 5 numbers. So if all relative frequencies, if all 6 of these numbers add to 1, then a shortcut, I really do need everybody to start to understand now, so we'll make probability chapter a whole lot easier. We could go 1 minus the number we did not want, and that will give me everything we do want. So even when we get to probability, you're going to hear me say it like that. 1 minus what I don't want gives me what I do want. And that is going to be a critical shortcut we're going to have to use, because when we get to probability, it's not going to be where, oh, I'll just add up the 5 numbers. It's going to be an impossible amount of work that was in here, but this guy's going to be really easy to do. So you'll be able to go 1 minus, pretty easy thing to calculate, will give you what all of this big mess would have been. So that's why I did that on that one. My Zoom, I'm struggling with a little bit. Let's see. Same part D. Oh, no more than 4, making sure you know that that means 4 or less, so just checking that word, right? And so again, the only thing I don't want is the 5 case. So 1 minus the 5 case is the shortcut. And of course, less than 5 means 4 or less, so it's the same thing as D. Okay, so one's supposed to be too hard, just make sure you do understand that language. All right, any questions on that? All right, so last time we gave you the recipe or the guidelines to how to make a histogram. Well, let me back up. We had done the special case of 1 bar per number. I think I probably asked you how many cats you had. Then we gave you the guidelines when you have to group it. So now we're going to do a histogram start to finish. We're going to do 1 now. And that's why for homework, if everybody, I don't care what Monday section you're in, for homework, if you'll take the 1220 data, I want you to do a histogram on Twitter, and I'll put up the answer key next time. That way you'll have 2 complete histograms in your notes. Okay. Let me see. I think I'm going to do Instagram, but let me see. Yeah, I'm going to do 1220 Instagram data. Okay, 1220 Instagram data. Instagram, histogram. Okay. Now, Friday seems like so long ago. Did we talk about zeros and how they can be okay, good. So I don't have to give you that spiel. So we are going to not use those zeros. I assume if you put 0 on Instagram, you don't have an Instagram, so we're not looking at those zeros. Of course, please make your life easier and look at the right-hand side of the 1220 data. First thing I'm going to do is count up the number of data points. Looks like there's 30 data points. Okay, so we said that the number of intervals should be approximately the square root of n, approximately, no calculator. What's square root of 30? Approximately. Pick an integer. 5. Is that what you said? You said, huh? Well, you could have said 5 or you could have said 6. They're both perfectly fine answers. Remember we said we just need to get in the ballpark. There's absolutely more than one correct way to make a histogram. You can use the number 5, you can use the number 6. I do not care. Because I thought you said 5, I'm going to go with 5. Because we got to pick a number, right? But you could redo this whole thing using 6, and that would be okay. Now, our second one was the width of the interval, or what are we counting by? And we said it's max minus min, Instagram. And then we were going to divide by this number that how many intervals we're using in number 1. I'm going to take the time to get that exact to then show you. My calculator's half dying this morning too. So that gives you 580.4. Now nobody is going to count by 580.4. Of course, you can do 580, but I want to really show you how lazy you can be. You don't even have to count by 580. You're welcome to back up to 550 or go forward to 600. I love zeros, so I'm going to go forward to 600. Again, you can count by 580, you could count by 550, you like 575, go for it, or 600. Again, all you got to do is be in the ballpark. Now, what are we going to start at? Let me look. Oh, I think we're kind of easy here. It doesn't get any easier than 100. So, I don't even, if this had been 104 as the lowest Instagram, I would have backed up to 100, so you have some freedom there too, but, can't make 100 any easier, so we'll go with 100. Okay, so now the first thing I'm going to do is get organized into a frequency distribution. Okay, so number of Instagram followers, and we're just going to do frequency. We're not going to worry about relative frequency. All right, I said I was going to start at 100 and that I was going to count by 600, which is the width of the interval, meaning my first interval is 100 to 700. I got to count by 600s, and there should be a natural question that arises in just a minute, and I'll answer it in just a minute. I got to count sixes. 6, 6, 6. Okay, first of all, I've gotten lucky. Usually when I am making a histogram, I usually always end up with one more interval than what I had said I was going to do, and that's perfectly fine. It's still in the ballpark, so don't worry if you say you're shooting for 5 intervals, you end up with 6, perfectly fine. I got lucky, I ended up with 5, but rarely ever happens to me. Now there should be a question, I should be confusing you on something right now. So you may have a question about my intervals.
So 5, like you didn't get that from like the square root of 30, you just chose.
No, well, I did. Square root of 30 is either 5 or 6. It's somewhere between 5 or 6. You could have chosen 6, you could have chosen 5. I just chose 5. I had to choose one of them.
If it's 700, does it go on the first?
Yeah. So if it's 700, where does it go? So, not just my rule. All statisticians decided on this rule. So all you need to know is this. If a data point falls on the endpoint, put it into the higher interval. So 700 would go in the 700 to 1300, okay? Now, the next 2 minutes, I don't even know if you want to write it down, but I know how you've probably seen these things through middle and high school, so I just want to, or even if you're Googling, you're looking in a different textbook, maybe your science book or something, just to show you how some other books label it. Some books use the closed parenthesis, open parenthesis notation. Some books will use that, the bracket and the open parenthesis, but a lot of people don't know what the bracket and the open parenthesis means. So sometimes that's not very helpful. Some books will use the dash and then the less than sign, which does make sense if you can keep up with your less than and your greater than sign. It just makes it maybe a little more awkward to read. So this is more standard convention, and this is the way I want you to do it, just trying to show you some other ways. In middle school, maybe high school, so maybe you shouldn't even write this down because it hurts my brain. I always have to think. You may have seen that. Now, you might be sitting there saying, yeah, lady, because that's super clear. Why don't you like that? It works for our Facebook data because we could only, or Instagram, whatever we're doing, because you can only have whole human beings, right? But if your data has, 1 decimal place to the 10th spot, then you would have to make that 2499.9. If your data's out to the 100th spot, you'd have to make that 2499.99. It's like every time you have a different data set, continuous data depending on the decimals, you're going to have to change how you do that. I always like to teach, if I can, one way to do something that will always hold. If you use this way of writing the intervals, it will allow you to do any data set that you come across. All you have to know is this one rule. That's it. Also, we're about to make a histogram. That's our ultimate goal, right? And I've seen a lot of middle schoolers, because this is very popular, this notation in middle school, then when they go to make the histogram, they really don't know how to label it. They don't know if they're supposed to be showing the 2499 and the 2500, and then a space gets in between, and there's not supposed to be spaces between the bars, and it just opens up a big mess. So, do it like this, know the one rule, it really doesn't get any easier than that, okay? We have to go count up. I'm going to count up, you guys can check my work. I'm looking at the ordered Instagram follower data, and I'm going to look to see how many are between 100 and 700. And again, If someone comes up with something different, feel free to correct me. Okay, so let's say 24, 28. There's my 30 people. So again, what I've made so far, this table of organization is called a frequency distribution. We're going to make the histogram in just a second. Is that okay? Okay. Now, if you want to make your life easy, who doesn't want to make their life easy, right? I'm trying to get a quick sketch. I'm not interested in graph paper. I'm not a computer. I know I need to mark off my x-axis evenly. Yes, you can mark it off however you want and then go squeeze your bars in. But we know our intervals have equal width. So if you want to make your life super easy, go ahead and tick it off, but then label them with your interval endpoints. So this is one. I'm going to have to write a little bit bigger than I normally would just so you can see it, right? And unfortunately, what I'm doing here, I can't see on my computer, so I have to kind of keep looking here. I am labeling the tick mark. And that's really, really important. I just had to write it kind of big so you could see it. I am not labeling the white space in between. I am labeling the tick mark. Okay, does everybody understand that? So like this 100 is supposed to be the label for that tick mark. Now, I need to get up to 12. Maybe I'll count by twos. 2, 4, 6, 8, 10, 12. A few things, but well, let me do my bars and then I'll say some stuff. 12, 12, 4, nothing, 2. Something like that. Is that okay? So, this little space here, a lot of times I'm asked about that space. That's that art of statistics. It's like an indentation. No, that's not the word. It's like margins on your Word document. You know, there's the default margins, but you can always go into Word and change them a little bit if you want. SPSS does it. Most books will do a little margin just because they know if the bar is right up against the y-axis, it's just kind of hard to see. It's just not as readable. That's all it is. This is pure aesthetics, okay? This does not have to be to scale. We are not viewing on the x-axis this as 0. My graph starts at 100 and goes to there, and all of this is to scale. So kind of different than probably your XY origin graphing that you did in high school. This is just an indentation, okay? Now, of course, the y-axis, yes, that is 0 on the y-axis. But on the x-axis, I don't have to start at 0. I'm basically starting at the minimum of my data set, which could be 1,000,000 depending on what my data set is. And probably within 5 minutes, we're going to get these words formally. But see how most people had somewhat lower, or they were all kind of clumped in here together, and you had a few stragglers with some extra high number of followers. Again, this is an example of right skew, and I'm going to put these words up formally in just a couple minutes. Is that okay? Any questions on that? Practice one more. We'll check it next time. This is where I think if you practice 2 histograms start to finish on your own, it's probably enough practice for histograms. But let me show you this whole thing that I keep saying, you have to be in the ballpark. And yeah, some students might have 5 intervals, some might have 6, some might have 7, and it's all perfectly fine. None of us want to do 3 and 4 and 5 different histograms for the same data set and look at them. It's a bit tedious to do by hand, so that's when you go to the computer, right? And you grab an applet. So this is real data. It was from Old Faithful, the geyser. the data that I'm going to show you is actually not how long it erupts for, but how long it lays quiet or dormant in between eruptions. I think they had like 200 and, I had it, let me see if I find it really quick. Yeah. It was 200 or 250 data points. So if you take the square root of that, you should have about 15 intervals, okay? I think I have like 20 different histograms here, just to show you what happens if you are not using enough intervals, show you what happens if you have too many intervals, and how there's quite a few histograms in the middle in the ballpark that are perfectly fine. So we were shooting for about 15 intervals. You can see if you don't have enough intervals, it's very blocky. You can't really see the trend in it at all. Now on the other extreme, if you have too many intervals, well, I would prefer that to too few intervals. To me, it's always look like a heart machine or something. It's just a little bit busy. So somewhere, I think actually this may have been technically the one with exactly 15. It doesn't really matter. Any of those 6 are perfectly fine histograms. There's not just one that's correct. So that's what we mean about getting in the ballpark. Also, this is a chance to show you something called bimodal. I'm going to put that word up on the board in just a minute. See how there seems to be 2 mountains? You can kind of almost view it as 2 different things. This will be called bimodal. Mode just means mound or mountain or clump. So there seems to be 2 different things going on, and that's really important in real life. I'll be honest, in the classroom we don't look at data nowhere near as much as we should because it's tedious. It takes a whole lot of time to pull up SPSS and get it to show you what the data looks like. There's just not time. But in real life we always want to see our data set, because if someone just gives us results and we don't get to see the data, we might miss that it's bimodal. And bimodal can be a bit of a dangerous animal. We're going to start talking about mean and median today. If you calculate the mean or the median on bimodal data, it's probably going to fall somewhere around in the middle, what I call no man's land, like in the valley between the 2 mountains. It's describing nothing. It's totally useless piece of information. But if you didn't know it was bimodal, you might think you were actually calculating something good. Because if you were getting a mean or median in between, it's not describing the longer times that it's laying dormant. It is not describing the shorter times. So in real life, we will split up bimodal, and then we'll give you means and medians for the longer times. And then in a separate discussion, we'll give you means and medians for the shorter time or whatever. So it is really important to look at your data first in real life, maybe not in the classroom. All right. I think I'm going to put all those words like I keep saying. Yeah, so this was part of chapter 2.2. It's called Smoothing Out Histograms or Skew. Okay. People usually talk about smoothing out histograms. Honestly, you can smooth out stem and leaves. You could smooth out a dot plot. It doesn't really matter. It's just histograms tend to come up probably more frequently. Data sets can look like a lot of different things, right? But it just turns out there seems to be about 4 very common shapes that we see. These shapes are not going to describe every data set, but a lot of data sets tend to look like one of these 4 that I'm going to show you. Okay, I put that. So let me go ahead and put up the shapes first. Nope, because I don't know my left from my right, people. That's why you guys are writing in pencil. I'm writing in pen just so you can see it. Yes, because I don't know my right from my left. See, I'm all confused here trying to work with this dot cam. I already told you you had to be patient with me today.
We're going to talk about each one, but let me just attempt to get him up. Oh, he's pretty. I did good on, no, he's not. I'll squeeze in my other guy. Now, at first glance, you might be like, where'd these pretty mountains come from? Histograms and stem and leaves, they weren't quite looking like that. You don't have to draw this, but if you could imagine, and that's what I was trying to do on the last couple graphs that we've done in class, maybe there was a histogram behind here. Think our Instagram a minute ago or whatever, right? And so basically all I did was smooth it out and then I erased my bars. So I'm just showing you what I call my ski slope, okay? But these shapes are representing that we had a graph in the background, we just kind of smoothed it out, and we're just looking at the general feel for it. Okay. Now, there are some synonyms. Right skew is also called positively skewed. I tend to use right and left words more often than the positive, but left skew is also called negative skew. Negatively skewed. They're just synonyms. Symmetric, I mean, I've done better than I normally do. We're talking about symmetric across the middle, so the left-hand side will match the right-hand side. If you cut it in half, that's not too bad. Bimodal, just two mountains. Now, you will notice I put unimodal on the first three, because there seems to be one clump. But unimodal is like calling you guys humans. You are human. But I think I could probably get a little more, specific, right? And that's where that skewness comes in, or the idea of symmetry. On the skews, you've got to memorize it properly. It's where the tail is headed. It's not where the clump is. And it's opposite, of what most students think. See how this tail is on the right-hand side? That's why it's called right skew. This tail is on the left-hand side. That's why it's called left skew. So it's wherever the dinosaur tail is headed, okay? That you don't want to memorize them wrong, because that'll mess you up on my test. All right. Examples of each. Right skew is probably the most common that I come across. Basically, almost all social media that I see is right skewed. It kind of makes sense because if you're on social media, I don't know, you probably have at least 100 friends, right? And if you're just a normal person, define normal, right? But you're probably not going to have, I'm going to talk about Facebook, you probably wouldn't have more than 4,000 or 5,000. Now, 100 to 5,000 might seem like a pretty big range, but if you compare it to like celebrities, who I don't know, 1 million, I have no clue, or at least 500,000, then yeah, most people are kind of in the big clump. Then you're going to have a few higher values. And that really happens with almost all social media. House prices and salaries in real life are right skewed in most areas, in most professions. Because again, a house usually can't be but so cheap. You don't normally get a house for $10. But houses can go up to millions. I don't care where you live. Rockingham, I would say most houses are 150,000 up. Let's just say even 500,000, 600,000. Well, still, those are really different homes, 100,000 to 600,000. Most people are in there, but even in Rockingham, there are $2 million homes, so you would get more extreme values. You can add probably 300,000 to those numbers for Northern Virginia, right? But then you have the really extra expensive homes. Salaries, the same thing. These ideas of house prices and salaries I'll probably keep talking about because when you read about this stuff in newspapers, actually I'm going to compliment the newspapers. I'll probably start picking on them next week again. But for house prices, most newspapers, it seems to be either every Sunday or once a month, or they'll give you the quarterly info on house prices. because it doesn't even matter if you own a home. House prices are directly tied to the economy. So much of talking about the economy, they'll talk about the house prices, because then most people can kind of relate to that. So you'll hear and read about house prices in the newspaper. It doesn't matter if you're looking to buy or sell a home. Anyway, most of the time they will talk about the median, which is what they should be doing. We'll be putting that up on the board in a few minutes. But if you know something is skewed, you are not to use the mean. You have to use the median. Again, I'll be putting that in your notes, hopefully today. But so the newspapers do a good job there, because they know it's skewed and they're not supposed to be talking about the mean. They're supposed to be talking about the median. Left skew. I always struggle with left skew. I mean, I guess I could eventually Google it, but I want to give you more the big idea. So these are all my opinions at this point. Left skew. How about United States lifespan? I think, I've never really checked this out, but I feel like in America, most people live to older age. I mean, unfortunately, of course, there are still babies and children and teenagers who die early, but I think most people live to older age, so I'm thinking lifespan might be left skew in America. What does that say? I do so much better on the chalkboard. Desired test scores is what I meant to say. Desired test scores. Your desire and my desire, okay? All of us want lots of hundreds and 90s and 80s, right? We don't want very many 10s and 20s and 30s. So all of our desired test scores, I think, should look left skew. Symmetric. Gosh, so many things in biology. I mean, adult and biology, nature is what I mean. Adult female heights or adult male heights. Just don't put the males and females together, because then it's probably going to become bimodal. Anything manufactured, okay, assuming the machines haven't broken down. If you're talking about ketchup bottles, okay, I'm making up numbers here. I hate ketchup, first of all, but I always talk about ketchup. If there's a 16-ounce bottle, I'm going to assume that Heinz or Hans, whoever, is probably aiming, I don't know, to put like 15.7 in there, because if you put too much ketchup, it's going to, make a mess, right? Now, but Heinz also knows this. It wants to be really tight and close around that target of 15.7 ounces. Because first of all, if they put too much, it's going to start to come out of the top and it won't seal and they'll have a big mess at the factory. If they put too less ketchup, we're going to be able to see the empty spot, the empty space, and no one's going to actually pick it off the grocery shelf to buy it, right? And believe it or not, there are crazy consumers out there. There is a real story of a woman who apparently bought a lot of ketchup bottles. She pretended or somehow was able to measure all the ketchup in the bottles and then sued the ketchup company for not putting enough in there. My guess is she didn't know how to get it all out because it kind of sticks to the sides, right? But there are people who love to sue companies. So Heinz wants to do the correct thing. So if they're shooting for 15.7, when they do their quality control checks throughout the day, they're going to graph their results, and they want it unimodal and symmetric, nice and tight around 15.7 ounces. And if it's not, if it doesn't look like that, they're going to shut down the machine because it means the machine is broke. So if the machines are working properly, anything manufactured should be. One other thing I want to briefly talk about, because I don't know if everybody knows this, SAT scores are forced here. They are forced to be unimodal and symmetric. Are forced here. I honestly don't know what, first of all, I hate SAT scores, and if I have any freshmen in here, you probably know that 5 months ago was the first incoming class at JMU where SAT scores are optional. So there is a movement away from them, but anyway. I don't really know what the raw scores for SAT scores look like. I've never pulled that up. And I don't even know if you know that the score you sent into JMU was not your raw score. It was called a scaled score. Now I can argue this both ways. There are, what, 6 Saturdays in a year or something that SAT tests are given. And all those students throughout the entire year are competing for the same application process for colleges. So they need everything to be fair. What if they write too hard a test for one given Saturday? And they get all the scores back and it looks like everything's in the 300s and the 400s, like, oops, we made this too hard. How can these students now compete with the one we gave in March that was considerably easier? So they will scale everybody up. I think the targeted is 500 for the mean with the standard deviation of 100. So they take all the raw scores on any given Saturday and they make it fit a curve that is centered at 500. So that's why they do it. They want to keep it fair. But let me make sure you truly understand what this means. Now, this is never going to happen. It's a ridiculous example. I always try to use extreme examples to help you understand an underlying concept. Let's say the next time the SATs are given, only the geniuses show up. The rest of us normal people, we decide we're going to sleep in. Okay, only the geniuses. Those that get, you know, like 1550 and 1600 out of 1600, okay? So when College Board gets all of these SAT scores back for that Saturday, they're going to be like, oh my God, we made it too easy. They're going to scale everybody back. So on any given Saturday, by its very nature, there's no way around this. 50% of students score below average and 50% of students score above average, and it doesn't matter who showed up. It is forced there. And you kind of think, especially not everyone's taking it anyway. You probably have to have some interest in college at all or whatever. So it's kind of interesting that 50% of students on any given Saturday will score below average on the SAT, and that's just the way it is. So again, it's something to debate. There's pros and cons to it, but that is how SAT scores work. Bimodal, we don't do too much with bimodal in here. I showed you Old Faithful, kind of looks like 2 mounds. If you did the adult male and female heights, it would probably look like that. Of course, there's intersection, but you would see 2 clumps. So, all right. That's all I want to say there for now, I think. All right. I think we're going on to some notes, trying to get myself organized here. Hold on. My notes are over here. Yeah, so there is still one more graph we're going to do, but we're going to take a little detour and talk about the mean and median first. My goal was to get you introduced to the calculator today. I may not reach that goal, but that's okay. I'm going a little slower because I'm trying to do the doc cam. Describing the center of a data set. Where is most of the data centered or clumped around? Again, these 2 words hopefully will be familiar, mean and median. There is a little bit of notation you want to make sure you're absolutely memorize if you've never seen it. We have the mean, that's the average, right? Technically the word is not average. You should call it the mean, but I'll be the first one to call it average sometimes. So the mean, add them up, divide by how many, right? Add them up, divide by how many. Now, I'm not big into summation notation, but I do think everyone should know what the summation sign is, and maybe I should write it a little more carefully. This big old E thing there, it's capital sigma. That means to add up in math and stats. So that an X usually represents the data point. You add up all your data points, divide by how many, okay? Now, if you know summation notation, you know I made it a little bit easy. I'm supposed to have a sub I equals 1n. I don't want to show all that. Makes it look complicated. Now, all of statistics is all based on, hey, we take samples to let us help estimate the population, right? So we have different notation for the sample mean and the population mean. Sample mean is X bar. Population mean is Greek symbol mu. If it's anything, it's a U with a little tail on the left. It is pronounced with the M sound. But I find that a lot of students start to turn that into a cursive M. That is not an M. If it's anything, it's a U. Okay? But it's pronounced mu. Now the formulas are the same. It's really how I'm referencing you. Who has an easy name that I can pronounce the first and the last name? Jackie Dews. Jackie Dews. She is Jackie. She is Miss Dews. It's a different way of referencing her, but it's still the same human being, right? So if you are my sample, I'm going to reference you as X bar. You are a sample of all my Math 220 students. If that's how, or you're a sample of JMU students, if that's how I'm referencing you, I'm going to reference you with X bar. But maybe you're the only 70 students I care about. You're it. You are my population, then I'm going to reference you as mu. But if I was getting the average, I'm still going to just go around and add up and divide by how many. The formula would not be the same. She didn't morph into someone different when I called her by a different reference, right? So it's this, it would be the same number if I have the exact same people in front of me. Now, obviously in real life, the sample, if you're a sample of JMU students, well, if I go next door to the next classroom and get a different sample, they're going to have a different number from you, right? So a lot of times, of course, in real life, we'll have lots of different X bars. They're all different numbers, and they're trying to estimate the unknown population mean mu. Now, this is one of those things, these little X bars and mu's are going to be thrown on the board for the next 4 months. And when I throw them on the board, I do expect that you know what they mean, just like you know your own name. So if you're unfamiliar with that notation, something to stick on a note card and own it for the whole semester. The mean is affected by outliers, or I haven't given you a definition of an outlier. Really right now we're just talking about unusual values. Something kind of big or something kind of small. We'll get specific definitions for, or criteria for outliers in the future, but. So thus the mean is only good for symmetrical distributions. It should not be used for skewed. I do know for a fact that the president at JMU will at least co-teach a class every semester. I mean, obviously he is not teaching 3 days a week every single week, right? But he will, because he wants to keep connected to the students. So we'll group him in with faculty. So if you took faculty salaries, math department, English department, whatever, and you threw the president in there, and hey, we'll throw the football coach in there too, right? Well, hopefully you see where I'm going with this. I hope you do know this. The president and the football coach make a whole lot more money than the rest of us. Now, I did purposely leave out business professors, but they still don't make as much as the president. So, but anyway, if you take that, then most of us are here, and you've got the president and the football coach, right? So their two values are so high, remember we're adding them up, dividing by how many, it's going to pull the mean upwards. You don't want just 2 data points affecting the entire data set. It could technically pull it up so high where then the number you have describes nobody. It's higher than most faculty members, but then lower than those two, so it's a useless piece of information because of the idea that we're adding things. So what are you supposed to do if you have skewed? That's what the median is for. Okay, the median. Hopefully you remember, you put the data in order and take the middle value. Good news, you're not going to be doing this by hand. Our calculator is doing it. But you should know what your calculator is doing, right? We call it resistant to outliers. Okay. A synonym, it's not used that often, but the second quartile. We'll get to our other quartiles next time or the time after that. The second quartile, because if you have 2 quarters in your pocket, you have 50 cents, and isn't that what the median is? It is cutting your data set in half. 50% of the data set is below the median, 50% of the data set is above the median, right? So that's why it's called the second quartile. Sometimes you'll see it written as Q2 for the second quartile. Now, what's interesting, the median does not get different notation for sample versus population. Actually, the median is not real powerful for the rest of the statistics we're going to do. Almost all of Math 220 will be based on the mean and the standard deviation. We will do a little bit more with the median probably next time, and then we will leave the median, and it really doesn't come back again in Math 220. So that's probably why it doesn't have the notation. Yeah, this is probably a perfect stopping point. So next time we're going to get introduced to the calculator. Now this wasn't real hard, right? Because it should be reviewed. But you know how you make anything harder? You make it word problems. So mean word problems, weighted mean next time is probably the first time that if anybody's going to struggle, that's where you're going to struggle. I know it's Friday, so please come anyway to class, all right? I'll see you Friday. I think my homework is still